In example 2, we are told that a water wave travels 12 meters in 4 seconds. If the frequency of the wave is 2 Hz, calculate the speed of the wave and the wavelength of the wave. Let's start with the first part. In this first part, we are asked to calculate the speed of the wave. At the mention of the word speed of the wave, we think about two equations. The first one is the one which we dealt with in the first example, which was speed of the wave is equals to frequency times wavelength. Now, in any problem solving, you need to think of the shortest way to arrive at the answer. For example, if I want to calculate the speed of the wave using this equation, I realize that although frequency is given, because 2 Hz is the frequency, the wavelength is not provided. Now, speed can be calculated using another equation. Speed can be calculated by dividing distance by time. You really need to keep your mind open when you're solving problems. You realize that 12 meters is the distance which is covered by the wave, and 4 is the time taken to cover that distance. So you realize that in this first part, we can just calculate the speed of the wave by dividing the distance by the time. The distance covered is 12 meters, and it covers that distance in 4 seconds. So dividing 12 by 4, we get 3, and dividing meters by second, we get meters per second. This means that the wave covers a distance of 3 meters every second. So remember, in problem solving, think of the shortest way to arrive at the answer and think of alternatives. These alternative methods will be suggested by what is provided in the question. For example, it occurred to us that the shortest way to arrive at the answer to the first part is by using this relationship. It's because the distance and the time has been provided. Always ask yourself, why is this physical quantity provided? Can this physical quantity be combined with another one to give me a third physical quantity? Those are some of the questions which you need to consider. Now let's look at part B. In part A, we have already worked out the speed of the wave as 3 meters per second. Now in this part, we are asked to calculate the wavelength. Now you also realize that it would not have been wise for us to use this equation to calculate the speed. This equation here, we considered the possibility of using this equation in part A, and we saw that there was an easier method. It does not mean that this equation wouldn't have been used, but for us to use it in part A, we would have been forced to work out the wavelength of the waves so that we can combine it with this frequency to get the speed. But then you realize that whatever we needed in part A is what has been asked in part B. This kind of mistake happens quite often in problem solving. You find that in an attempt to get the solution to part A, you may work out some physical quantity, and when you check in part B, you find that that which you worked out in part A is required in part B. That clearly tells you that the kind of method you're trying to follow for part A is not the correct one. It is not the method that the examiner intended that you follow. That kind of mistake occurs quite often, and you will agree with me, if you've been solving questions, you have encountered something like that. That is, in an attempt to get the answer to part A, you calculate other physical quantities, and those other physical quantities, some of them have been asked in part B. So you end up like doing double work. So always be careful. When you're working out a quantity, when you find that that quantity is required in part B, chances are such that the examiner did not intend that you follow such a method. For instance, in working out the speed of the wave in A, the examiner clearly did not intend that we follow this equation in part A, because by following this equation, we would calculate lambda in part A, and yet we find that lambda is required in part B. So always be on the lookout for such mistakes and such difficulties, and they can be solved by more practice. So in part B, we needed to calculate wavelength because we know the speed and we know the frequency. By the way, the frequency is just 2 Hz. There's a frequency, and the speed, we have worked it out as 3 meters per second. So we can go right ahead and substitute here, and we find that the speed is 3 meters per second. The frequency is 2 Hz times the wavelength. Now, something else that I need to point out about frequency. Frequency can also have the units per second. In other words, if we are told that this frequency is 2 Hz, we can write it as 2 per second, because frequency is the number of happenings per second, number of oscillations per second, number of vibrations per second. So it is number of happenings per second. So over here, so that these units can cancel out, this will be in per second. This will be 3 meters per second. By the way, meters per second can be written as meters seconds raised to -1. It is read as meters per second, and this one is also meters per second. This is the slash notation, while this is the scientific notation. The per second will cancel out. Of course, there is lambda here, and you'll find that lambda is equal to 3 meters divided by 2, which is 1.5 meters. And this is the wavelength of the waves. The wavelength is 1.5 meters. Alternatively, instead of substituting into this equation as it is like this, I would go ahead and make lambda the subject. Now, how do I do that? If I'm provided that V is equals to F times lambda, and I want to make lambda the subject, I will therefore divide both sides by what I don't need. I don't need frequency on this side. So I divide by frequency, and lambda becomes equal to speed over frequency. So it is just a 3 divided by 2. That is exactly what we have done here to get the value of wavelength. Let's stop this question at this point and look at example 3.